Alright, in the last tutorial, gradient of a curve, tulikuwa tunaanza hii topic niite ya differentiations. Lakini sasa mtu ambaye anaingia A level akiuliza kuhusu differentiation, moja ya maneno ambayo atayasikia haraka sana kuuliza differentiation, utaambiwa kuna kitu kinaitwa dy dx. Lakini ukiangalia ile tutorial ya gradient of a curve, hakuna mahali tulisema dy over dx, au kama wengine wanavyoita dy dx. Hakuna mahali, japokuwa tulikuwa tuna discuss differentiations. So in this tutorial now, we are going to introduce hiyo concept ya dy dx. Okay, so let us begin now introducing that concept of dy dx. Okay, now consider hii graph hapa. Okay, ambapo tuna curve hii PQ. It's a section of a curve where point P ni x, y and point Q ni x1, y1. Okay, so as a point moves from P to Q, the value of x changes from x to x1. Kwa hiyo change in x is just x1 minus x. Now this change in x is denoted by this symbol, which is inasomeka kama delta x. Kiandika delta x naandikwa hivi, delta x. Okay, and now not just x is changing, y is also changing from y to y1. So the change in y is now y1 minus 1, which is denoted by delta y. Na yenyewe nasomeka hivyo, delta y. So the average rate of change of y as x changes from x to x1 is just equal to y1 minus y over x1 minus x. But what is yy minus y? It is delta y. And what is yy and what is x1 minus x? It is delta x. So the average rate of change of y as x changes from x to x1 is delta y over delta x. Now this delta y delta x is the slope of the straight line PQ. Okay, the straight line PQ. But we don't want to deal with the gradient of a straight line. We want to deal with the gradient of a point P, of the curve, not the gradient of a straight line, but the gradient of a curve at point P, x, y. So as we learned in the last tutorial, the gradient of a curve, the gradient of a curve at point P, x, y is just this, is just the limiting value of this gradient of a straight line PQ as P and Q are very close to each other. That means as the difference of x or change in x is very small, or you can say it approaches zero. Hii sasa ndio gradient of curve at point P. Gradient of curve at point P, x, y. Na hii sasa ndio tunaita dy dx. Sasa welcome to differentiations, okay? Welcome to differentiations, dy dx. So check this out now. In the last tutorial we dealt with this equation here, y equals to x squared. Now I'll give you a question. I say find dy dx. So I'm going to assume I have a curve with 2 points, P, x, y, and of course Q, x1, y1. Akiniambia ni find dy dx, I know he wants me to find the gradient of a curve at point P, x, y. Okay, which I know that dy dx is just equal to the limiting value of delta y. We have already seen what delta y is. delta x as delta x approaches 0. Now, what is delta x? Tushasema kwamba delta x is just the change in x. And what is delta y? Tushasema kwamba delta y is just a change in y. So you can see here, from here I can obtain that x1 equals to x plus delta x. Hii kumbuke, x nikileta tu huku. And from here I can obtain that y1 equals to y plus delta y. Hii pia ikumbuke. Sasa I am looking for dy dx, or the gradient of the curve at point P, x, comma y. So I know that y equals to x square, lakini at point Q manake y1 equals to x1 squared. So change in y1 minus y ni sawa na x1 squared minus x squared, kwa sababu y si x squared. Sasa follow along this algebra, tutafika somewhere, tutapenda. Okay? Hapa ni maana kuna algebra nita solve, zitanifikisha mpaka hapa ninapotaka. y1 nimesema ni hii hapa, y plus delta y kwa minus y, na x1 nimesema ni hii hapa, x plus delta x kwa maana yake ni squared minus x squared. So I mean this goes, so we get delta y equals to, square this one is just x squared plus 2x delta x plus delta x squared minus x squared. So can minus that one. So my delta y now equals to 2x delta x plus delta x squared. Naweza nikatoa nje delta x here. So my delta y is just equal to delta x, it's just 2x plus delta x, can divide by delta x both sides, and this part by delta x. So I'll obtain here that my delta y over delta x is just going to be equal to 2x plus delta x. Now this is a gradient of the straight line PQ, or the average rate of change of y as x changes from x to x1. But I'm looking for dy dx, or the gradient of a curve at point P. So okay, nimefika mpaka hapa kwamba delta y over delta x ni sawa sana 2x plus delta x. Sasa mimi nataka dy over dx. Hiyo ni limiting value ya huyu as delta x approach 0. Maana ni limiting value ya huyu hapa as delta x approach 0. So ona, as delta x approach 0, inavyozidi kuwa karibu na 0, the value of delta y over delta x inazidi kuwa sawa na 2x. Okay? Kwa sababu kama delta x ni 0.00001, it means kwamba it approaches 0. Inakaribiana sana kufika 0. Maana yake 2x plus 0.00000 is just almost itakuwa ni 2x.00000. So inakaribiana na 2x. So the limiting value is 2x. Is 2x. Or in other words, kama tulivyosema in the last tutorial kwamba no matter how Q gets closer and closer to P, I mean the gradient will never be less than 2x. In other words, naweza nikasema hivyo. Now this 2x sasa ndio gradient of a curve at point P, and this 2x now ndio dy over dx. Hii ndio 2x. Now remember yesterday we were dealing with the gradient of curve at point 2 P2, 4. Ya equation hii ambayo tumeshughulika nayo hii hapa ya y equals to x squared. Manake katika point hii sasa, manake x mbili, manake dy dx. Sawa, ni sasa na 2 mara 2 ambayo ni 4. Now remember in the last tutorial the gradient of a curve at point P ilikuwa ni ngapi? Ilikuwa ni 4. Kwa the gradient of a curve at a particular point gives us dy over dx. Okay, we shall learn more in the coming tutorial. But for today to share hapo, it's happy to introduce dy dx in differentiations.